Hey there, what's going on? Today we're going to be talking about how to solve for a variable when we're given a diagram of intersecting lines. While these types of problems definitely have a high school geometry vibe to them, the solving skills we need to use to get to the end aren't any different from the ones that we learned in Algebra 1. The only difference here is that we need to create the equations that we have to solve. So the obvious question is, how do we do that? Well, you start by identifying the relationship between the angles that you have. These relationships are going to compare in only one of two ways. They're going to be congruent, and if that's the case, then you're going to set your two angles equal to each other. Or they're going to be supplementary, and if that's the case, then you take your two angles, slap a plus in between them, and set the whole thing equal to 180. Now there's a lot of different relationships between angles. In this video, we're going to keep things basic. We're only going to look at two relationships: linear pairs and vertical angles. The table you see on your screen tells us everything that we need to know. A linear pair is any pair of adjacent angles that form a line. This basically means that your two angles have to be side by side, or if it makes it a little bit easier for you, that the two angles share a side. Since a linear pair is defined as any two angles that make a line, this means that they're automatically supplementary. So our solving process is going to be to take our two angles, add them together, and set them equal to 180. Vertical angles, on the other hand, are defined as any pair of angles that share a vertex. These angles are going to open up in opposite directions, and they're congruent. So when we go to solve, all we have to do is set the two angles equal to each other. Alright, so we have all the information that we need to successfully solve for variables when we have linear pairs and vertical angles. Identify the relationship between the angles and either add them together to equal 180 or set them equal and solve. Let's take a look at a few examples. Our first example asks us to solve for x when we have this diagram right here. So the first thing we need to do, even before we care about the actual angles, is to see their relationship. These are side by side, which means that we have a linear pair. Remember, linear pairs are supplementary, and what do we do when we have supplementary angles? We add them together and set them equal to 180. Our first angle was 75, our second angle was 4x plus 5. These parentheses are to help us differentiate between our two angles, by the way. And of course, we set the whole thing equal to 180. Once we're ready to solve, we can drop the parentheses here. That's going to give us just 75 plus 4x plus 5, and that's going to equal 180. I see that I have two numbers here. They're like terms. I can combine them. So I'm going to have 4x, and then 75 plus 5 is 80. That still equals 180. Now I have a two-step linear equation. I minus 80 from both sides to get rid of the 80. That cancels out over here, and we get 4x is equal to 100. I need to get rid of that 4, so I'm going to divide both sides by 4 because it's timesing by x, and that's going to give me an answer of x is equal to 25. See what I'm saying about how these solving skills are the same as what we learned in algebra class? Just because we're doing something with angles doesn't mean that the steps, the rules of algebra, are going to change. Listen, I hate to generalize here, but I feel like you'd benefit from hearing this. Anytime you have a pair of angles that are supplementary, the steps are basically going to be the same. You take your two angles, plus them together, set them equal to 180, combine your like terms, plus or minus the constant over to the other side, and then divide by the number in front of the variable. I also feel like I should emphasize the fact that x is not the measure of the angle. X is x. If you're trying to figure out how big that angle is, then you need to take your x and plug it back into the 4x plus 5. That's not our goal here, though, so for now, let's just be satisfied that we could even find x. Fantastic. Well, hopefully you're feeling good, because it's time to move on to the next example. Our task here is the same as before: solve for x. Always start by identifying the relationship between your angles. Here I have this angle on the left, like so, and this angle on the right. They share a vertex and open in opposite directions. That fits one of our definitions real nice. These angles are vertical angles. Once we know our angles are vertical, then we can set up our equation. We know that vertical angles are congruent, so we're going to take our first angle, 113, and set it equal to our second angle, 5x minus 7. And now this is a simple two-step problem. We didn't even have to combine any like terms. We have 113 is equal to 5x minus 7. To get x by itself, start by adding 7 to both sides like this. Crosses off there, 113 and 7 makes 120, equals 5x. To get the x by itself, we need to divide everything by 5, and that's going to give us a value of x that is 24. 120 divided by 5 is 24. Now that's what we in the business like to call a best case scenario. You know what I'm talking about. It's one of those problems where everything just works out nice. Now granted, I can't promise you nice numbers all the time, nor can I promise that this will be the end of most of your work, but if you ever have vertical angles and you have to solve for x, well, here you go. Pretty straightforward. I should mention here too that you'll notice that even though our two angles were basically horizontal from each other, they're still considered vertical angles. Remember, the definition of vertical angles is just that they share a vertex. They open in opposite directions. So, regardless of the types of relationships that you have between your angles, if you're trying to solve for a variable, you first need to identify that relationship, and then you're either going to add the two angles and set them equal to 180 if it's a supplementary pair, or you're going to take the two angles and set them equal to each other if they're congruent. After that, all you got to do is just solve like algebra class. And that's it. I'll be honest, I don't really have anything else to say, so I'm just going to go ahead and sign off. See ya.